All right, 6-5, logistic growth, how populations grow. Okay, now we're going to deal with logistic curves. You've dealt with this before in pre-calculus. What you need to remember is that this is your max, and this is where we're getting to the max. Okay, so let's move on. So here it says the growth rate of the population of bears is newly established with the wildlife preserve is modeled by this differential equation right here, where t is measured in years. So the first thing we need to know is what is the carrying capacity? In other words, what is your max? So with your max, remember we said that's right here. So your max is going to be 100 bears. Okay, let's go to the next one. For B, what is the bear population when the population is growing the fastest? So what you want to think about here is your equation. So dp over dt is equal to 0.8p minus 0.008p squared. What we have is a parabola. It opens down, so it's something like this. So this point right here is going to be your max. So what we're going to use is we're going to use our vertex. If you remember back from pre-calculus, x equals negative b over 2a. So therefore we have negative 0.8 over 2 times negative 0.008, which is going to give you the answer of 50. So when the bear population is 50, that's when it's growing the fastest. Okay, now let's move on to C. And for C, what is the rate of change of the population when it is growing the fastest? All you have to do is plug it in. So we've got 0.008 times 50 times 100 minus 50. So what we have is 20 bears per year. All right, it's your turn. Go ahead and pause and give it a go. Okay, and here's the answer. Okay, next one is the moose population. So let's make a little bit more room. Again, we know how to do the carrying capacity. So A is just going to be 1,000. And then for B, you just stick that into your graphing calculator and do that. So this is for calculator. Let's move on to C. So for C, it says solve the differential equation with initial condition of P sub 0 or P at 0 is equal to 61 and show that it conforms to the slope field. So once you get the equation, you want to put it in with your slope field on your calculator and show that it follows the pattern. So in order to do this, we need to take our dp over dt, and we need to go that this is equal to 0.0003p times 1,000 minus p. So we're going to go ahead and solve this. So we're going to put dt over on one side and your p's on the other side. So I've got 1 over p 1,000 minus p dp is equal to 0.0003 dt. And then on the first part here, we're going to integrate all of this. So this first part, we're going to have to use our partial fractions. So I've got that a over p plus b over 1,000 minus p, therefore I've got a 1,000 minus p plus b p is equal to 1. And if I go ahead and solve these, then I end up, first I'll put in that p is equal to 1,000, therefore b is going to be equal to 0.001, and then I'll put in that p is equal to 0, and therefore a is equal to 0.001. 1 as well. Okay, so now we're going to go ahead and do our integration. So, okay, let's go ahead and separate this so I can finish this. I've got the integral 0.001 over p plus 0.001 over 1,000 minus p, and dp, and I end up with get my pen, 0.001 natural log of p minus, because remember you had to take the derivative of this and it's a negative p, so minus 0.001 natural log of 1,000 minus p. All right, and then if we go ahead and put these two together, what we're going to end up with is 0.001 natural log of p over 1,000 minus p. And then that's going to be equal to, because when we take the integral here, we would get 0.0003 t plus c. Multiply everything by 1,000 just so we can get these numbers down a bit. So we've got the natural log of p over 1,000 minus p equals 0.3 t plus c. I want to get rid of my natural log, so I'm going to go this to the this. I'm going to put it into exponential form. So e to the 0.3 t plus c is equal to p over 1,000 minus p. And I want to flip this one here. So to flip it, I'm just going to go negative. So now I've got e to the negative 0.3 t minus c equals 1,000 minus p over p. Let me make this a little bit smaller. Okay, so now going from there, I've flipped it, and the reason I flipped it is for this reason. I've got e to the negative 3t minus c equals 1,000 over p minus 1. So now that I've got that, I'm going to take my 1 over, so I've got e to the negative 3t minus c plus 1 equals 1,000 over p. And then I need to go ahead and use the fact that I had p sub 0 is equal to 60. Let's go ahead and put that in there. And so what I have now is I've got e to the negative c, because when I plug in 0 for t, I just get negative c, plus 1 equals 1,000 over 60. So I end up with e to the negative c is equal to 939 over 61. From there, I'm going to go up here, and I've got e to the negative c is equal to 15.393. So I'm going to go back to where I was at, to right here, so that I have 1,000 over p minus 1 is equal to 15.393 e to the negative 0.3 t. So if I solve for p, just using our actually algebra skills, I end up with 1,000 over 1 plus 15.393 e to the negative 0.03 t, and this should be a 0 here too. And then I'm done. Okay, this is one for you to try. Go ahead and give it a try. I'm going to go ahead and put the answer, so go ahead and pause. All right, here's the steps, and here's the final answer. Okay, the next one we're going to talk about is logistic growth models. Again, this one here is your carrying capacity, or your max. And then the MK is your growth. Okay, so here we've got an equation that says use your logistic regression. All you're going to do is put this in the calculator, so let's go ahead and make this smaller. You're going to put it in the calculator, and then you're going to come up with an equation, and the equation you get is y equals 31640.7129 all over 1 plus 23.5766 e to the negative 0.103 x. Okay, and then from there you're just going to use your information. So it says use a logistic regression of the data superimposed on a scatter plot. So that's where on A you're just plugging it in and then do a scatter plot. So for B, it says based on the regression equation, what will the aurora population approach in the long run? So that means what's going to be the most it's going to get, and that's going to be your carrying capacity. So it'll be 316,441. We'll just go ahead and round that up. Okay. For C, based on the regression equation, when will the population of Aurora first exceed 300,000 people? What you can do is just set your equation equal to 300,000 people, and then right here, all over 1 plus 23.5766 e to the negative 0.103 x. So there's two things you can do here. You can either solve for x using this equation, or you could say this is y1 equals that, and then y2 equals this, and find out where they intersect, and you'll find out that they intersect at the 59th year. And then we want to do D. And for D, we know that M is equal to 16,440.7, and we know that MK is going to be 0.1026, and so, or I guess we could say 1,3. That's this one right here, MK. So to find K, right, we're just going to divide by M, and we get K is approximately 3.24 times 10 to the 7th. So now if we just plug all of this into that original equation of dP over dt is equal to Kp M minus P, what we'll end up with is that dP over dt is going to be equal to 3.24 times 10 to the 7th P times the same thing, 3.24 times 10 to the 7th minus P. And you're done. Okay, here's one for you to give it a go. So go ahead and give it a go. I'll put the answer in for you. Go ahead and pause. All right, here's the answer. Here's some problems that you can do that will help you practice all of these concepts.